This is the second question. Here we want to prove that f vector is 0 and also find its scalar potential. To find f is irrotational, we should find del cross f vector is 0. So del we know that I vector into dou by dou x plus j vector into dou by dou y plus k vector into dou by dou z. So del cross f vector will be, first write I vector, j vector, k vector, dou by this, write this fully, dou by dou x, dou by dou y, dou by dou z, and write the y, I, j, k term of f vector, y plus y square plus z square, x plus z plus 2xy, y plus 2xz. Now I vector, close this I vector and write the components of j and k, dou by dou y into y plus 2xz minus dou by dou z into x plus z plus 2xy minus j vector. Close this j vector and write the components of I and k, dou by dou x of y plus 2xz minus dou by dou z of y plus y square plus z square plus k vector of, close this k vector and write the components of I and j, dou by dou x of x plus z plus 2xy minus dou by dou y of y plus y square plus z square. Now differentiate this with respect to y, which is 1, and 2xz will become 0, and differentiating this with respect to z will give this as 0, this as 1, this as 0 because there is no z term. So 1 minus 1 minus j vector. Differentiating this term with respect to x, this term will become 0, and here 2 into 1 into z, which is 2z, minus dou by dou z. We are going to differentiate this with respect to z. This will become 0, this will become 0, there is no z term, this will become 2z, plus k vector into, differentiating this with respect to x, this is 1, this is 0, this will become 2y, minus, differentiating this with respect to y, this will become 1, this will become 2y, this will become 0, there is no y term. So all the terms are getting cancelled, so 0. So we proved that it is irrotational. Now we are going to find the scalar potential. To find scalar potential, we have to equate f vector equal to del phi. F vector is y plus y square plus z square into I vector plus x plus, we are equating dou phi by dou x, dou phi by dou y, and dou phi by dou z. Now we want only phi, so integrating these will give phi, integrating this will give phi. In the other side there is no x term, so multiply x on all the terms. Here dou phi by dou y, integrating this will give phi. Here no y term, so xy. Here no y term, so yz. Here y term is there, so 2x y square by 2, 2 will get cancelled, xy plus yz plus xy square. Here no z term, so yz plus, here z term is there, it will become 2xz square by 2, phi equal to yz plus xz square. Now we want to write the constants. To write the constants, keep this in mind. We are differentiating this with respect to x, so we are going to write the constant in terms of other two terms y z. Here the same way x and z, here y, x and y. Now we want to write all the things in together. This should not repeat. If we write xy, then in another time there should not be xy. So likewise we want to write here. Now xy is there, we already wrote xy, so don't want. Then yz is there, xy square we already wrote, yz we wrote, xz square wrote. So this is the answer. Along with we have to write constant c. We should write where c is, we should write the addition of this and this and this g2 and g3, g1 of y comma z plus g2 of x comma z plus g3 of x comma y.